Okay, 2.5, Fundamental Theorem of Algebra. The Fundamental Theorem of Algebra says, for any polynomial with degree greater or equal to 1, the degree is equal to the maximum number of possible roots. So if it's x to the fourth, you're probably going to have 4 roots. If it's x cubed, you would have 3 roots, etc. You sometimes have less because of the multiplicity, but in general, remember that your degree should equal how many roots you have if you account for that multiplicity. So, zeros that are square roots. When you have irrational zeros, also complex zeros, you end up with a pair, a conjugate pair. It will say, or it says, you always have positive and negative, whatever that root is. So, if we tell you x equals root 3 is one of these solutions, you automatically know x equals negative root 3 is the other solution. And oftentimes we only give you one of them, and you have to remember, oh yeah, these are conjugates. So I have to remember the other root or solution on my own. I mentioned it earlier, complex solutions do the same thing. They have conjugates also. So just to get the point across, if I tell you x equals 2 minus root 7 is a solution, then you would come in with your pencil before you get started and say, oh, that's right, that means x equals 2 plus root 7 is also a solution. You only change the symbol in front of the square root sign. Think about quadratic formula, right? Quadratic formula has that plus minus. This plus minus right here is what we're talking about. They always come in pairs. Same idea for complex. If I told you x equaled 3 plus 5i, you would be able to say, okay, well that means x equals 3 minus 5i is another root. Only change the symbol in front of the I. Notice in both of these cases, the 2 didn't change and the 3 didn't change. Only in front of the square root or the imaginary piece. Okay, so then how do we find all the zeros if we're given a zero that is, in this case, a complex number? So I just want to quickly review. Remember, if I told you x equaled 4 was a 0, then you would know by kind of doing opposite of zero product property, minus 4 from both sides. X minus 4 would have been the factor, because zero product property with x minus 4 gives you a 0 of 4. So it's kind of that same idea. I'm just going to highlight my way through this one because it's already worked out. You take the 0 they give you, and you start moving things to the other side. So the first thing they did was multiply by 3 because they wanted to get rid of that fraction. If I multiply by 3 on that side, I have to multiply by 3 on that side. Then they distributed the 2. And then you just keep moving things over. Minus the 2 to that side, plus the 6i to that side. Eventually you get, well, it's this one over here that you get. But they put the black box a little higher. Right at this step, you could remember, well, if it's 2 plus 6i, there's also, if it's 2 minus 6i, there's also a 2 plus 6i partner. Or I tend to do it at the last step. Right here where I circled my answer, 3x minus 2 plus 6i, the other one must be 3x minus 2 minus 6i, because you only change the symbol in front of the I. So those would be my 2 roots. Let me circle that one in red. So when we give you one complex 0, we're actually giving you 2, which gives you the 2 factors. Then they took those 2 factors, here they are circled in red, it doesn't matter which one goes where, and they multiplied them together. Notice these 2 boxes are opposites, and these 2 boxes are opposites. So when I add those together, they go away. And then when I deal with negative 36i squared, this is really negative 36 times I squared is negative 1, which is really 36, plus this box that's 4 is where that 40 comes from. And then they combine like terms with the rest of the boxes. So let me go back to regular numbers off on the side. If I know 2 is a factor of 12, let me just write 12 at the top. And I know 3 is a factor of 12. It divides evenly into 12. Then I know 2 times 3, 6 is a factor of 12. I can divide 12 by 2. That works. I can divide 12 by 3. That works. And I can divide 12 by 6. Each of those works on their own. So that's what we've done over here in red. I took my 2 factors that were circled in red, multiplied them together to get this new one. I'm going to circle it in green. That must be a factor of our original question circled up here in purple now. That means that if I do division, and this is not the way we've taught division, I should remove that from your notes, I'll do it on the side, it should go in evenly. So the way you guys learn division, I have my open area diagram. It needs 3 because I am dividing something that has 3 into it. I'm not sure how big it needs to be yet, so I'll just leave it open-ended. Okay, you are taking our green answer, 9x squared minus 12x plus 40, and you are dividing it into that circled purple one I have at the top. So that means the first box needs to be 9x cubed. So then to get 9x cubed, this is our long division area diagram. The left times the top needs to make 9x cubed, so this needs to be x. The left times the top. Then the left times the top. Then remember, what color am I going to use? Dark blue. These 2 boxes, here and here, need to add to be the next number in my circled purple equation at the top. So to get negative 57x squared, I've got negative 12, so negative 45x squared. The left times the top, so 9x squared times negative 5 would make negative 45x squared. The left times the top. The left times the top. And then I need to check my diagonal. This one and this one need to make that one. That works. And my last one, this one needs to be that one. It is. Check. I have no remainder. That is what this was doing. This is just a different way to do long division. It's fine if you know how to do that way, but it's not something we've taught. So since that worked, I have my last factor is x minus 5. So I'm back here in this box. If I know the factor is x minus 5, then the last root must be x equals 0. So now, did I say x equals 0? Sorry, x equals 5. I know my zeros are the one that was given, 2/3, 1 minus 3i. Its conjugate, 2/3, 1 plus 3i, and 5 that we just found. Okay, I understand that might have been a lot. It's a little awkward when it's all written there for you, but for some people they find it helpful. Let's work through this one together. So we've given a 0, we need to find the remaining zeros. So I am given x equals 1/2 1 minus I root 5. So this one's got imaginary and square root. Either way, if it was just imaginary or if it was just a square root, we have to remember that it has a conjugate. But let's work on moving everything over to the other side, right? So I could distribute 1/2, but that's just going to make a mess out of everything. So instead, get rid of 1/2, multiply both sides by 2. 2x equals 1 minus I root 5. Keep moving everything back to the left. Maybe you don't need to show as many steps as I am. one of my factors is 2x minus 1 plus I root 5, because that has to equal 0. So that's one of my factors. Logically then, because it comes in a conjugate pair, my other factor must be 2x still minus 1, but minus I root 5, because those are conjugates. You only change the plus minus in front of the root or the I. In this case, it's the root and the I. Now I need to multiply those together. So 3 by 3 feel free to pause the video and multiply those together. One of them on the bottom, one of them on the side. Go ahead and pause it. I'm going to stop showing my work. When you unpause the video, I'll have filled in my area diagram. Okay, so check your area diagram with me. Notice positive 2xi root 5 crosses out with negative 2xi root 5. Negative I root 5 crosses out with positive I root 5. And then things always happen in this other corner. Negative I squared is negative 1. And then root 5 times root 5 is just regular 5. Multiply that all together, and this box is just 5. When you finish multiplying complex conjugates together, you should have no i's left. They should all either cancel or simplify like they have in this one. So putting this all together, I have 4x squared, negative 2x and another negative 2x is negative 4x, 1, and this 5 is plus 6. This factor that I got from multiplying those other factors together must divide into, I'm going to go purple again over here, this polynomial. So, long division. Let's set up an area diagram. I'm dividing 3 things in. Not exactly sure how long it's going to be. To be clear, I am sure how long it's going to be, but I understand you guys might not be. That's why I do it this way. So just give myself some space and then leave the rest of it open. I am dividing 4x squared minus 4x plus 6, the answer I got when I multiplied, into the circled one in purple. So first term, 8x cubed. This one needs to be 8x cubed. The top times the left needs to multiply to be that. So 4x squared times this must be 2x. See how that multiplies to be 8x cubed. The top times the left, negative 4x times 2x, negative 8x squared. The top times the left, 12x. Now I do my diagonals. This box plus this box needs to equal the next term. So negative 8, I need negative 6x squared to get 14. Top times the left, I know you might think it doesn't work. It works, it's just that it's going to be a fraction. So maybe I need to do a little bit of work on the side here. When I do work on the side, I just write aside. This is just my scratch work. So the top, well, how about I do it like this? The left, 4x squared, times something, I'm just going to call it z, has to equal negative 6x squared. This is what I'm trying to solve. So if I'm trying to solve for z, divide by 4x squared, divide by 4x squared. That missing number is going to be, let's reduce this, negative 2 goes into both of those, so 3 over 2, and the x squareds cross out. So negative 3 over 2 times 4x squared will make negative 6x squared. Negative 3 over 2 times negative 4. Sometimes it's easier if you divide first. Negative 4 divided by 2 is negative 2 times negative 3 gives me 6x. Same idea with this one. 6 divided by that 2 is 3 times negative 3 gives me negative 9. And then I check my diagonals. 6 and 12, 18. And negative 9, negative 9. Remember, it's supposed to work. I have no remainder. It's supposed to work because we gave you the roots. So it wanted me to find all remaining zeros. Just to be safe, I'm going to list all the zeros, the one that I gave you. Its conjugate. Remember conjugates, you just change the symbol in front of the I or the square root. And, okay, last step. I'm at 2x minus 3 halves. Maybe I need to do an aside with that also. Normally I can do zero product property in my head, but maybe this is too much. 2x minus 3 halves equals 0. 2x equals positive 3 halves. Divide by 2, that's 3 over 4. So we found all the zeros based on the one they gave us. Okay, now we are going to find all the zeros of this polynomial. Notice we gave you nothing, so you have no choice but to use your P over Q's. So rational root test, plus or minus P over Q. See if you remember how to do that. Pause your video and see if you can come up with the list of possible factors. What factors are we going to try? So remember, it's factors of P, which is the constant, divided by factors of Q, which is the coefficient. So numbers that go into 3, 1 and 3. Numbers that divide into 2, 1 and 2. And then I did every combination. 1 over 1, 3 over 1. And then 1 over 2, 3 over 2. So how many possibilities is that? Don't forget it's plus or minus. So you have 8 possible. Positive 1, negative 1. Positive 3, negative 3, etc. This is pretty reasonable, 8 possibilities. If we were in class, I would have you all try a different one. But since we're not, set up a synthetic division table. You only need the coefficients. 2, 7, 5, 7, 3. And then try one of those factors until you find one that works. Remember, you know it works when you get a remainder of 0. Okay, you can try this on your own or you can follow along with me. I've been doing this for a while, and so I'm going to tell you negative 3 works. But on test day, you wouldn't know what worked until you tried it. Go ahead and do synthetic division with negative 3 and see what you get. Pause your video. Okay, so there's my synthetic division when I used negative 3. I know it worked because I got remainder of 0. Now, I could put the x's back in this. This would be 2x cubed plus x squared plus 2x plus 1. But this is still a cubic. I can't do anything with that yet. So I'm going to need to do synthetic division again. When I need to do synthetic division twice, I like to just keep going underneath. So the only thing is, that I've divided this a little bit, so now I might have fewer P over Q's. So if I do my synthetic division, and I look at where my new P would be, and where my new Q would be, my new P over Q for my smaller, plus or minus, for my smaller polynomial is now 1 over 1, 2, which is just 1 and 1/2. I should write equals. Plus or minus. So maybe 1 works, maybe negative 1 works. Maybe 1/2 works, maybe negative 1/2 works. Why don't you try synthetic division until you get remainder 0? So you would try whatever you could. I already know negative 1/2 will work. So if you haven't yet, try negative 1/2 and see if you can remember how to do synthetic division with fractions. Remember the extra step. What do you do when you're doing synthetic division with fractions? So the 2 comes down. Negative half of 2 is negative 1. Add. Negative half of 0 is 0. Add. Negative half of 2 is negative 1. Add. I did get remainder 0. What's the extra step? When you do synthetic division with a fraction, you need to divide out that denominator. So I'm going to divide these answers by 2 before I ever put x back in my answer. So this is 1, 0, 2, about 1. Divide everything by 2. Now I can put the x's back. This is constant. This would be x. I'm going to write it just because. And this would be my x squared. So I finally got it down. It's a little weird with the 0 in the middle. To x squared plus 1. But I'm still trying to find all the roots. Remember, this problem has degree 4, so I should have 4 roots. And so far, I only have 2. So set it equal to 0. You could do quadratic formula if you want, or minus 1. X squared equals negative 1. Square root both sides. What do you have to remember when you square root both sides? Plus or minus root negative 1. Don't forget the plus minus when you square root both sides. Then what is the square root of negative 1? It's I. So my zeros are the negative 3 that worked, the negative 1/2 that worked, positive I, and negative I. Those are your conjugates. You got 2 of them. So when you finish the problem, 4 zeros. Okay, going backwards. So use these zeros. Here are my zeros at the end. Find the polynomial of least degree in expanded form. We usually say with integral coefficients also. So least degree just means don't throw in any extra x's that we didn't give you. Expanded form means it needs to all be multiplied out. So if x equals 4, what is that as a factor? If x equals 2 minus I, what is that as a factor? And do you know anything else about that last one? See if you can turn these all into factors. Okay, so we are undoing zero product property. So it must be x minus 4. It must be x minus 2 plus I. And then remember that was a complex zero. So that means it has a complex conjugate. So you must also have another factor of x minus 2 minus I. So we're halfway there. We kind of know our polynomial must be f of x equals this. But this is in factored form. It clearly says expanded form, so you must multiply this out. Always multiply your conjugates together first. I talked about how when you multiply conjugates, all those i's should cross out. So if you're super careful and you set up an area diagram and you multiply those two together, you should get a nice polynomial. Once you do that, you'll multiply it with the other factor to get your final answer. Set up and multiply x minus 2 plus I and x minus 2 minus I. Pause your video and get that answer. Okay, so check your area diagram with mine. When I multiply it all out, those corners, not corners, but those spots always cancel out. Negative I squared is negative negative 1, which is just 1. So that part gives me x squared, combine like terms, minus 4x, 4, and 1 more plus 5. So that was the orange factors that I put this orange bar on. Don't forget, you still have to multiply that by x minus 4. So now you have one more area diagram to do. I've run out of space, so I'm not going to show my area diagram. Oh, I didn't run out of space, sorry. I will set up my area diagram, but I'm not going to show my work. I am now trying to multiply the x minus 4 times the answer I got earlier. So x minus 4, I guess I'll do it upside down, times the answer I just got, x squared minus 4x plus 5. Okay, pause your video and see if you can get the correct answer. Okay, check your area diagram with mine. And then they wanted the polynomial of least degree in expanded form. This is an expanded form, but you need to make it a polynomial function. You will lose a point if you forget to make it a polynomial function. So don't forget the f of x or g of x or whatever you want equals in order to get full credit. So if I did synthetic division with this and I divided it all the way down, the zeros I would get would be those there. Okay, one more same idea, but this time I gave you irrational zeros. So turn those zeros into factors. See how far you can get. Okay, so undo zero product property. It must have been a factor of 4 and then a factor of x minus 3 plus root 2. And then did you remember your conjugate? If you see a square root, one of them with a minus, the other one must be with a plus. Move it all over and you get x minus 3 minus root 2. These are conjugates again, so always multiply your conjugates together first. Theoretically, you can multiply in any order. But if you make a tiny mistake, because there's going to be roots along the way, it's going to be a mess. So always multiply your conjugates together first. Make a 3 by 3 area diagram if you haven't already. Multiply those ones together. Remember, nice things happen when you multiply conjugates together, so it should come out looking much nicer than it looks right now. Then when you get that answer, you'll need to multiply that answer times the one x minus 4 that we haven't used yet. So I'm going to need a 3 by 2 box. So here's what we're going to do. One of these sides is going to say x minus 3 plus root 2. The other one's going to say x still minus 3 minus root 2. You're going to multiply that out. Then your answer is going to go here, and you're going to multiply it by this x minus 4 that we haven't used yet. See if you can do this one on your own. Pause your video. Okay, so check your answers in both area diagrams. Notice, and I am fine with you doing this, I crossed those two boxes out without even filling them in, because the more of these conjugates boxes you do, multiplying conjugates together, the more you catch on to those boxes are going to cross out anyways, so who cares? Also notice root 2 times negative root 2 is negative regular 2, plus this 9 here is where my plus 7 came from. So then I took that answer over here, multiplied it out, wrote my polynomial as a function. Don't forget f of x equals in your answer, and I'm done. Hope you guys are doing good.